I'm going to talk about systems of linear equations, including their solutions. I will assume that you know what a linear equation is. If you don't, I would invite you to watch the necessary videos. All right? So, suppose we had the following linear equation. So, the solution set of this linear equation is a set of points consisting of pairs of values, such that one of them corresponds to the value of the x variable and one of them corresponds to the value of the y variable. Okay? Now, another linear equation will have possibly a different set of solutions. Okay? Now, to solve a system such as this pair of linear equations, what that means is that you find points that don't just satisfy the top equation or the bottom equation, but both of them at the same time. Okay, let me repeat that. To solve a pair of linear equations, you have to find points that solve both equations at the same time. Okay? So, for example, the first linear equation has a set with several points in it, such as 0, 1, 1, 0, 1/2, 1/2, etc., etc. Okay, the second linear equation has a corresponding solution set as well, such as 0, -1, 1, 0, 2, 1, and so on. Okay? What you need to do is you need to find points that show up in both of those blue sets. Can you see that 1, 0 is present in both? So the solution to this pair of linear equations is the single point 1, 0. Okay, again, because it satisfies both linear equations. To confirm that a point is a solution to a system of linear equations, you need to confirm that it's a solution to all the linear equations in the system. Okay? Let me do an example to show you what I mean. Suppose I had a system of linear equations consisting of these two linear equations. Now, suppose I thought for some reason that 1, 3 wasn't just a solution of one of those linear equations, but the entire system. How could I confirm that? Well, I could see if it's a solution to each linear equation separately. So let's go ahead and do that. In the first linear equation, I will replace x with 1 and y with 3. So 4 times 1 minus 3 gives 1, which is equal to the right side. All right, so that checks out. For the second linear equation, I will do similarly. I'll replace the x with 1 and the y with 3, and that gives 4, which is equal to the right side. So that checks out. So yes, 1, 3 is a solution of this system of linear equations. Okay, see how that works? Let's do another example. X plus y equals 1 and x plus y equals 2. And suppose we wanted to know if 0, 1 is a solution of that system of linear equations. So let me do the necessary replacements for the first linear equation. And that'll give me 0 plus 1, that equals 1. So that checks out. For the second linear equation, I will get 0 plus 1, which is equal to 1, and that does not equal 2. So no, this point is, the given point is not a solution of this system. Now, notice something interesting. Do you see how both equations have the same left side? Would you agree that no matter what values for x and y someone chooses, there's no way that x plus y is going to equal two different numbers at the same time? Okay, so there is no solutions to this system of linear equations. All right, now I would like you to try an example. Would you please determine if 0, minus 3 is a solution of the given system of linear equations? So pause the video if you like and determine that now. Okay, I'll go ahead and determine it as well. So I'll do the necessary replacements. 4 times 0 minus 2 times minus 3 gives 6. That checks out. Okay, 2 times 0 minus negative 3, that gives 3. That checks out. So yes, that is a solution. 0, minus 3 is a solution. Now, this is an interesting system of linear equations. Let me tell you why. There is actually an infinite number of solutions. All right, try 1, minus 1. You will see that that is another solution. Okay, in fact, find a number of solutions to either linear equation. Okay, and you will see that those same solutions are also the solutions of the other linear equation. Okay, if you solve one, you automatically solve the second one. Okay, so this allows me to mention an important point about solving pairs or systems of linear equations. You will only have the situations that you saw in the examples that I just did. You can have no solution. Okay, you can have one solution, or you can have an infinite number of solutions. Okay, those are the only three possibilities.